So, guys, if you turn in your books on your table to page 42, you should see investigation 3.1. So we're going to start by looking at the mass, volume, and density of various liquids. Now, we're really just looking at water, so I'll let you come one at a time to fill up the graduated cylinder. Can someone hold up the graduated cylinder? We're going to fill this up with 25 milliliters of water, okay? After that, we're going to use our balances here to take the mass of the water and the graduated cylinder. Now, if you look at the board, you see the graduated cylinder is about 35 grams itself. So when we take the mass of that plus the water, what do we need to do if we want only the water? And raise your hand, don't shout out the answer. Yes?
We need to subtract the weight of the graduated cylinder by the weight of the water.
Good. He said we need to subtract the weight of the graduated cylinder from the weight of the water. And let's try to use the word mass, because remember there's a difference between mass and weight. Okay? So, let me have table 1 and table 2 come back here and get 25 milliliters of water. Just one person from your table bring the graduated cylinder.
Okay.
Go ahead and get 25 milliliters. And when they get done, then table 3 and table 4 will go ahead and do the same thing. Use this sink right here. Hold on, that's what I call it. Okay, I'm going to use that sink. Be careful when you turn it on. There's a lot of pressure in it. So we do just like that, but turn it down a little bit. Actually, let me get table 3 can go ahead and use this sink over here. We got 3 sinks. And then we'll have these tables as well. And I will fill this one up for you guys. Thank you for staying so quiet as you wait for your group's turn. Be careful not to overfill it because that will affect your measurements, correct? All right, so you guys have once you have your 25 milliliters, you can have a seat. All right, table 4 can go ahead and get water. And then table 5, take one of your graduated cylinders and go to that sink. You need help turning it on? Alright. So pour a lot of that out, because you only want it at the 25 mark, okay? All right, somebody, why are some of y'all wearing goggles and some are not? Raise your hand. Haley?
I got
They got on glasses. Because they have on glasses already. Good. Going down. Yes. That'll be okay. That'll be okay. As close to 25 as possible, guys. If you're at 26, we'll work with that. If you're at 24, we will work with that as well. Remember to read the meniscus, so you're right at 31, so let's go over and roll that out. Okay, here we go. And it doesn't have to be exact. You got it, Ann? All right, here's out. Let's look at it. All right, so now what I want you to do is take the graduated cylinder. Can I use this group to demonstrate? So if you turn on your balance, okay, you're going to match the power button, and you need to wait for it to display 0, 0, okay? What you're going to do is zero it out and make sure it's in grams. There should be a small G in the top corner, and you guys can do this as I'm doing it. You're going to take your graduated cylinder with water and sit on top of it. Okay. This one should not be dead. I checked this one out this morning.
Ours ain't working either.
It's not coming on?
Ours isn't either.
Alright, 1 second, guys. That's with yours is working, Haley. Alright, so what number did y'all get? Read that out loud. So we will use their number. So I'm going to write on the board, you said 74.43. So if you're looking at your, yeah, so it rises and falls a little bit, but if you're looking at the top of your paper, you'll see the mass of the graduated cylinder, put 34.86. You're going to have 34.86 in that very first column. Then, right beside that, it says mass of graduated cylinder along with water. Okay? And so for 0 milliliters of water, what do you think our mass will be for that column? Will it stay the same? Will it go up or go down on that second column? It will stay the same. Thank you, Tanner. It will stay the same because we don't have any water in it. So you got 34.86 in those first two columns right here. Okay, because that's a graduated cylinder by itself. All right? Then, for 25 milliliters, Haley's group told us that it was, what, 74.44 grams, okay? So, if we have 74.44 grams, right? We're going to do 74.44, and we're going to subtract 34.86. So 6 from 14 will give us 8. 8 from 13 is 5. All right, so we get 39.58. And if we have to double check our work, you just add back in the amount of the graduated cylinder. Okay, so we get 39.58 for that second column when we have 25 milliliters of water. Does that make sense? 39.58. Do we have questions on how we got that number? Questions? So you're going to put it right here. So this mass will stay the same because it's the mass of the cylinder by itself. This one will stay the same. So guys, if we're looking at the column that says mass of graduated cylinder, will that number ever change? No. Remember that mass is what type of property? Chemical or physical? Those are your options. Raise your hand. Yes. It's a physical property, okay? So that's not going to change about the graduated cylinder. So it will remain 34.86 grams. But once we add differing amounts of water, it will change the mass, okay? So for the mass of the graduated cylinder and water at 0 milliliters of water, it's still going to be 34.86. Then when we add 25 milliliters of water, how much did you tell us it was, Haley? 74.44, right? Now, for just the mass of the water, we have to subtract from the graduated cylinder. So for the water itself, we get 39.58. For the water itself, we get 39.58. Yes. And what is our volume of water again? How much water did we measure out? Yes. 25 milliliters. Good. Okay. Now, raise your hand if you remember our density formula. We just went over this one briefly Friday, and I know we had a 3-day weekend. Do we remember the density formula? Density equals something divided by something.
Mass divided by volume.
Mass divided by volume, yes. Density equals mass divided by volume. Perfect. Tanner, can you go get your calculator out of your book bag for us? Density is going to be mass divided by volume. Okay? So to find the density, we're going to take, and we want the density of 1 milliliter of water. Okay? So we're going to take the mass of the water divided by the volume of the water. Does that make sense? And we will do that when he gets back in here. Now, can I have this group, just to save us some time, because I really want to get to the fun part, go and put 25 more milliliters in. Or actually, no, Haley's group, because y'all still is working. Add 25 more milliliters so we're up to 50, because we also have to look at 50 milliliters of water. And while they're doing that, let's set up our graph, okay? So, on our graph, remember we have to label our X and Y axis. So, what would be our X on our X axis versus the Y axis? Remember the X axis is what variable? Independent or dependent? Independent, good. So, it says we want to create a relationship between mass and volume of water. Between the mass and the volume of water. So which one would go on our x-axis, which one would go on our y? For the graph at the bottom, guys, which one would go on the x-axis? Mass or volume? Which one would go on the y-axis? Taylor?
Volume will go y-axis.
All right, good. So we've got volume here, mass here. Okay? Because our mass, or no, sorry, excuse me. Other way around, Taylor. Because think about this. Liquids, right? Water is a liquid. It's going to take the shape of its container, right? It's going to take the shape of its container. The mass is how much something is made up of. Does that make sense? We know mass is how much you're made up of. Okay? So mass, in that sense, will stay the same, whereas volume is what we're going to change and be measuring out. Okay? The mass of something is how much it is made up of. Alright, so in Haley's group, I'll need you to do something called tearing your scale here. So match that T. Oh, well, it's already zeroed out. If it's not zeroed out, you would match that T on it. Now place that graduated cylinder on there and let's see how much we have for 50 milliliters of water. And then move your hands away, give it a moment. Don't bump the table if you can help it. So what do we have? 97.83 grams. So in that final column, it says 50 milliliters of water. The mass of the graduated cylinder is still 34.86, correct? Yes.
Yes.
All right, now you told me the mass of the graduated cylinder and the water together was what?
97.83.
97.83. So what we're going to do is again subtract 34.86. So 6 from 13 will give me 7. 8 from 17 will give me 9. 4 from 6 will give me 2. 3 from 8 will give me 5. So we get 52.97 for the mass of the water itself. 52.97. And again, if you want to double check your answer, you can add back in the mass of just the graduated cylinder. Let's see. That was 2, that's 6, that's 7. Alright guys, that was a typo there, so that should be 62.97. 62.97, okay? And that was my one, excuse me. Alright, so check or hold on your chart. Do we have any blanks on our chart? Other than density. Any blanks other than density?
Isn't that supposed to be 97.8?
Yes, thank you, Drew. Thank you. But this was just, Drew, this was just me checking my work. So my answer is right here. 62.97. Okay? Good catch. So do we have any blanks other than density? Check or hold? Check or hold? Check. All right, so Tanner, with your calculator, we need to find the density for 25 milliliters of water and for 50 milliliters of water. So, what was my mass of water when I had 25 milliliters?
39.58.
So 39.58 divided by 25. Put that one into your calculator, Tanner, and let us know the density. And then the next one will be 97.83 divided by 50. Okay. No, 62.97, excuse me. Alright, Tanner, did you get that?
The first one is 1.5832.
Okay, so the density at 25 milliliters, 1.5832. So let's just do 1.58. 1.58. Alright, and then Tanner, the next one? What was that?
1.25.
So for the second one, it's 1.25. So those numbers are still relatively close to one another, okay? Relatively close to one another. So what I want you to do as your group, without me leading it, is to graph that. But we're going to come back to the graph because I do want us to get to the density column. So flip to that second page. Flip to the second page. Okay. So on your table right now, you should have 2 green beads, 2 clear beads, a nylon spacer, a steel cylinder, and then 4 cups to measure with. Now, if you have the graduated cylinder, you've got, you know for a fact that one goes up to 100 milliliters. These small ones right here also go up to that. So you're going to look at the very bottom line, and that will be your 25 milliliter mark. If you have the small cups, that's how you're going to measure that out. And you also have food coloring that we're going to put into the water, so that way you can differentiate the various levels. So in your books, turn to page 48. Turn to page 48, and that will go over how we're going to be doing this density column, okay? Now, with me, I have a lot of these materials, so I'll have one person from each group. I'll call you up and we'll pour the different materials. So when you come up, you need to bring all 4 of these small containers. Any questions? And if you don't have small ones, you'll bring your graduated cylinders, okay? All right, so starting with the first 2 groups, can I get Michaela and Colin to bring up your small measuring cups? So we're going to be measuring out vinegar, water, isopropyl alcohol, which is just rubbing alcohol, corn syrup, and vegetable oil. And you already all have water in your graduated cylinder, correct? So, if you have water in your graduated cylinder, Haley's group, y'all only need 25, so someone remeasure that for me. But the rest of you can put 1 drop of food coloring in that graduated cylinder so that your water is colored. Now, if you don't have food coloring at your table, give us just a moment because they only send you with 4 colors in a box and we have 6 groups. So, we'll sit this down and we will measure out 25 milliliters. Okay? All right, Michaela. Thank you. All right, here you go. So what I don't want you to do is get the vinegar and the alcohol mixed up, so please be very careful with that. Once you have one of them, you can take it back to your table and come get the next one. All right, here's your alcohol column. All right, you can sit it down on the table so it's flat. Thank you. There you go. All right, and now you guys will get vegetable oil, and then the corn syrup will be quite thick. Okay, there you go. And when this group gets done, table 3 can go ahead and come up. There you go. Kind of hard to open. Yes. Yes, give me one moment. Don't touch anything until you have some new ones. All right. Can I have Bozeman, my student assistant, come here, please? All right. So as you can see, that one is much thicker. All right. Go ahead. Go take Taylor some gloves so that she can swap hers out. The gloves are right here, sweetheart. Here you go, Michaela.
Where the gloves at?
Right there. All right, guys. So let's line up our stuff right over here, and you can just sit your cups down. Are you both in the same group? All right, perfect. So y'all can both hold one. So this is, I'm gonna give you vinegar and corn syrup, Drew. And guys, you can go ahead and look and discuss some of these items and where you think they might fall at. Yes, but not yet. We're gonna pour them in a certain order. So you can take those back. And then Jalen, I will go ahead and do the corn syrup and the rubbing alcohol for you, okay? Oh, that's a little too much. Let me go ahead and have Bozeman's group with y'all's graduated cylinders and things like that. All right, there you go. So I did give them a little too much. Hey, Jalen, come back because I did give y'all a little too much. All right, there you go. So this will be your cooking oil. Okay. Your rubbing alcohol. Please be careful with that. Can someone from the group come and help him so that these don't get wasted, guys?
I get bigger 14er.
All right. And then one for the vinegar.
Look.
Okay, there we go. All right, can I have Tanner's group come up? Tanner's group. And we're going to need all the graduated cylinder guys, so you can come on up. Okay. Hey guys, we need all 4 of the graduated cylinders, so let's go. Oh, keep the water. Y'all should have one more graduated cylinder at your table that's not water. Okay. So remember with this one. All right. And then I'll put the corn syrup so you can grab those too.
What is this?
That one is cooking oil. Okay. And then let me have Andrew and Colton come up with those other 2. Okay. All right, so we will put the tops on these things. So we've got our oil right here. So you guys, there we go. Then I will give you your vinegar. Okay. So someone can take the vinegar back. All right, and then the other 2 will have your cooking oil. Thank you. All right. And last but not least, our Cairo syrup. Okay. So, there you go. All right, so guys, as you're looking at your graduated cylinders, who remembers what that curved line is going to be called? The meniscus. Good, the meniscus. And I'm going to give you guys red. Put this in your water. And can I see you do it? Food color.
Like 3 seconds.
And you guys can use blue. All All right, now we are ready to build our density column. So you're going to be using these plastic tubes. And see, they're a little flimsy, so I would advise one person hold it while someone else pour things in. Does that make sense? So, if we look into our books on page 48, right? If we're on page 48, and I'll get my copy and put to that page, it should walk us through how we're going to build our density columns, okay? So, now, usually don't skip ahead in the procedure, right? But we've already measured everything out. So what it wants us to do, pour in, we're going to start with the corn syrup, okay? So you're going to pour in 25, well, the entire thing of corn syrup. Corn syrup is going to be the golden colored liquid, but it's the thickest, okay? So go ahead and pour the corn syrup in. Yes. Corn syrup, Karo syrup. You probably see your parents or grandparents bake with that a lot. So go ahead and pour those in. Pour the corn syrup into that clear tube. Okay, so don't hold it that way up like that, Drew. Make sure it's. Oh, that sounds good. There you go. All right, after you have finished with the corn syrup, good job. After you have finished with the corn syrup, then can someone read step number 6? After 25 milliliters of corn syrup, who's going to read number 6 for me? Step number 6. Taylor. Next, add. All right, quiet down so we can hear Taylor. So we just poured 25 milliliters of corn syrup. Then it says next add. So next we're going to add the 25 milliliters of vegetable oil. So go ahead and pour in your vegetable oil. That's going to be the next golden colored liquid, the vegetable oil. And what you should already see, guys, is either it's going to mix or you're going to see separate layers.
I'm blind. Give me a second.
All right, so I just noticed something. Zachariah's group. What were you just doing, Zachariah? So he was wafting it. He was wafting it because they weren't sure which liquor was which. And unfortunately, some of these have been used year after year, so theirs is a little discolored. So all of their containers look slightly golden. And it's not because they're dirty, but they've just become stained over time. So he was wafting to see which liquid was what. Okay? All right. After we added the 25 milliliters of vegetable oil, it says finally add 25 milliliters of colored water. Okay? So go ahead and pour in your colored water. Go ahead and pour in the colored water. Now, what you should see is 3 separate layers. Now, does it look like the water went below one of the layers?
Yeah.
Yes. Why? Raise your hand and tell me why you think the water went below a layer. Say that again? Because it's more dense. Because it's heavier. It's more dense. And what do we know about things at the bottom of the column? It's the most dense at the bottom of the column, okay? Now, what liquids do we have left to use? Vinegar and rubbing alcohol. Okay? So, what I want you guys to do is pour in your vinegar. Pour in your vinegar, and if you need to, you can waft it, right? Because vinegar and rubbing alcohol are both clear. So pour in your vinegar. Okay? And let it settle for a moment. Pour in your vinegar and let it settle. Okay. After you have poured in your vinegar, then you can go ahead and pour in your rubbing alcohol. And what you should still see is separate layers. Okay, so let that settle. Good. Okay, so the next thing we have to do. Now, raise your hand and tell me, did the liquids mix together or did they stay separated? Raise your hand. Let me hear from somebody. Colin. All right, are they still mixed together? Because what we should see is separate layers. Okay, let me see yours. It's possible that because some of them were clear. So we've got a layer here, a layer. Okay, so I see. I see 4 layers. So at the very top is a separate layer. It's a very thin layer. Okay. All right, so how many layers? 4. Alright, so Ansley, what did you just say happened to the colored water and the vinegar? Guys, listen to this. So she noticed that the vinegar and the water mixed together. Okay? When the liquids mix together, I'm waiting on table 1. When the liquids mix together, they're called miscible. Miscible. They mix together. But what we should see for the rest of the layers is exactly that, layers. They're not mixed. So they are called immiscible. Okay? If you look at number 8 in your book, number 8, letter A, it says, do the liquids mix together and are miscible? Or do they form distinct layers and they're immiscible? Okay? So letter B, I want us to discuss that one. What is the relationship between density of the liquid and the position in the column? What's the relationship between the density of the liquid and its position in the column? Raise your hand. The relationship between the density of the liquid itself and where it's located in the column. Jalen.
The density of the liquid,
Further down. So she said the denser the liquid, the further down, right? So we didn't complete our statement, but what she's saying is, the more dense the liquid, the further it is in the bottom of the density column. Does that make sense? All right, so now what we need to add are some of the solid objects we have. So I want you to add in both of the green beads, and don't, look at this, guys. If my hand was the density column, watch this. You do not need to drop them in like that and look for a splash, okay? If this was the density column, I'm going to go right to the top of the column at the edge and drop them down gently. And then give them a moment to settle and see where they land in, okay? So go ahead and put both of the clear beads and then both of the green beads. And you can go ahead and do that now.
Clear green first.
Yeah, go ahead and put the clear and the green. Go ahead and put the clear and the green. Go ahead and put the clear and the green. And then
right there.
wow. It's okay. All right, guys. So watch this. I know it's a little funny, but this is just going to be a learning curve. Where's one of their beads located? At the top as it slowly slides because it got stuck to the K-roll syrup, okay?
Oh my goodness.
That was the importance of not just throwing it in there. So he was following directions to drop it in carefully, but let's not drop it if we have sticky stuff on the side, okay? So it'll eventually slide down, and we see it's landing, it's on top of the water, right? But it's below the vegetable oil. Does that make sense? So it looks like it's right in between the vegetable oil and the water, okay? So go ahead and put in your clear beads as well. After you have your beads in, then I want you to go ahead and put in your metal cylinder, your metal cylinder, and be careful with that one, it's heavier, so definitely do not drop it in there. Kind of slide it down gently. Good. Put the metal cylinder, yes.
straight up.
It's not touching the. It's not touching the bottom.
Alright, so go ahead and now we're going to put in the nylon spacer. Yes, that's the black rubber thing, the nylon spacer. Okay. Alright, so this is what I need you to do with your group. I need you to go to that last page. To the last page, and if we don't complete this in class, it's okay. I need you to write down the items in our density column. Now, do we have 10 total items? No. No, we don't. So you won't fill up all 10 columns. Okay, so what's at the very, very bottom of our density column? The steel cylinder. So that should be listed as number 1, right? The steel cylinder. Okay. Tanner, can I see your groups? You guys, you can see all your layers. All right, so right below the steel cylinder, or excuse me, above that, what is next? Well, okay, don't just think about the solids. What about the liquid? So what's that liquid there? The Karo syrup. The corn syrup or the Karo syrup, yes. Right? The corn syrup or the Karo syrup. After that, what do we have in between the corn syrup and the water?
The
black thing, the nylon spacer. Nylon is Nylon. The nylon spacer. So number 2 is Karo syrup or corn syrup. Number 3 is nylon spacer. Okay? What's after the nylon spacer? The colored water. And how did we get the water to be a different color? The food coloring or the dye in it. Exactly. Okay? So just looking around at some of these. What do we have after we have, or is there anything mixed in with the water? Okay, so it's above the nylon spacer, but it's still in the water layer. Which beads? The green beads. The green beads. So, where are the clear beads at? They're at the top. So what does that tell us about the beads? The difference in the beads?
They're different densities.
They're different densities. Which ones have more density? The green beads have more density. That's okay. Put it in. So then, actually put green beads and then colored water. So hey guys, let's make a correction on our density column. Number 5 will be green beads. Number 4, let's see.
Color is green bead.
Number 4 is green beads. Number 5 is colored water. Okay, because the bead is below the water. It's within that level. Okay. All right, and then what did we mix with the water a little bit? Vinegar. So right above water is vinegar. So number 3 is vinegar. Okay. What is that level above the water and vinegar?
Number 3.
3 is vinegar.
Oh yeah.
Do we put clear beads then vinegar? Do we put clear beads then vinegar?
No, because the clear beads are above. So after the vinegar, guys, we've got oil. Then we have the alcohol layer, right? And then actually we've got oil, clear beads, and then the alcohol layer at the top. Okay? So oil, clear beads, and then the alcohol. Okay? So listen to the order of the items, starting with number 1. Okay? The steel cylinder, the corn syrup, the nylon spacer, green beads, the colored water, vinegar, oil, clear beads, and then the alcohol. Okay? Now, that was the alarm for us to pack up. So this is what I need you to do. This is what I need you to do, okay? I'm going to have one person from each group. Let me get Amelia, Eliana, Drew, Chaselyn, Tanner. Take the graduated cylinder and the things that you measured with, right? Everything except for your density column and any other things we used to measure. So basically the cups right here, go to the sink and I want you to rinse them out. There are paper towels, listen carefully before you get up. Paper towels at this sink only, so please don't make a mess. Remember the water has a lot of pressure behind it, so careful turning it on, okay? Everyone else at your table, you can remove your gloves and I'll come around with a trash can to collect those. And then, can I have Michaela come around and collect your goggles? Okay, I'll come and check on that just a moment. It is right over here, sweetheart.